There is more to logic in computer programs than the simple if-else blocks that you have learned about in the first few exercises here. In this video, I am thus going to explain another way that you can use logic in a computer program. Before I get on to that, however, let's first review the three main elements from which we construct computer programs. As we have discussed at length, variables are labeled addresses in memory. We can store values in the state of a variable. Functions are then used to change the state of those variables. And last but not least, logic allows us to make the behavior of the program, i.e. what functions are executed, dependent on the state of the variables. The logical structures we have learnt about thus far are the if-else blocks. An if-else block takes one or multiple variables in input. In this example, for instance, a single variable x is passed into the if block. The truth value of a logical proposition is then determined. In this example, we determine if the variable x has a value stored in its state that is less than 0. Then, if the truth value of the proposition is 1, one particular function is executed. If by contrast the truth value of the proposition is 0, a second, different function is evaluated. The way that this idea is translated into Python code is shown here. As you can see, we write the logical proposition after the word if on the first line of our block here. The set of instructions that are contained in function 1 are then written underneath this if statement in an indented block. The commands of function 2, by contrast, are written in an indented block that follows the unindented word else. Notice that the commands in these indented blocks can themselves be if statements. We could thus write a code such as the one shown here, where a further if block is executed if the proposition is true. We could also write similar code with an if block after the else. There is, however, a neater way that we can code this. Before getting onto this neater code, however, let's first consider what these sorts of commands are doing diagrammatically. As before, one or multiple variables, x here, enter our if block. We then determine the truth value for a logical proposition. X is less than 0 here, and one series of commands, function 1, is executed if the truth value of that proposition is 1. If the truth value of the proposition here is false, by contrast, we then determine the truth value of a second different proposition. In this particular example, x is less than 1. Function 2 here is thus only executed if the first proposition, x is less than 0, is false, and the second proposition, x is less than 1, is true. Function 3, meanwhile, is executed if both of these propositions are false. The way that we code this in Python is shown here. As you can see, this looks similar to the if-else blocks that we have been using thus far. Now, though, we have an elif sandwiched between the if and the else. This elif ensures that the truth value of the second proposition is evaluated if the truth value of the first proposition is false. In this code, therefore, y is set equal to 1 if x is less than 0, y is set equal to 2 if x is greater than or equal to 0 and x is less than 1, and y is set equal to 3 if x is greater than or equal to 1. We're not really going to use these if, elif, else blocks much in this exercise. I will instead just focus on using if-else blocks. We will need if, elif, else blocks in future weeks, however, so the quiz that follows will test your understanding of this concept. Good luck.